Welcome to our presentation today on a beautiful part of New South Wales coast in Australia. We have a beautiful sunny day, we have lovely wind and lots of sunlight and some waves behind us. Our talk today is on green energy. Many people are complaining about we don't have enough green energy. Some claims we don't need it. I believe we do need it, and this presentation is about giving answers to the green energy situation. My name is Alan, and I have developed baseload green energy. Baseload means you can leave your coal in the ground, you can leave your gas in the ground, and you can capture enough energy from natural resources to deliver power to your communities. In what form are we going to capture, or what are we going to capture? We have the sun, we have the wind, and we have the waves. If you go to a Google and punch in energy supplied in 1 cubic metre in 1 hour, you will find the sun will give you about 130 watts of electricity. The same article will give you the answer. You have about 300 watts to about 400 watts available from wind energy. Waves, covering the same 1 square metre, will deliver up to 30,000 watts. So what we are going to be chasing obviously is where most power is. This presentation is about baseload green energy based on the ocean waves. Does that mean we can go out there and capture these waves coming in now? No, we can't. Those waves, nearly all the energy is out of it because it's been dragged along the ocean floor as the waves meet the land. Our requirement is we have to capture the energy about 2 kilometres offshore. There are many reasons why we need to be 2 kilometres away, but that's where ocean waves still exist before they come coastal. How are we going to capture it? We will use pressure plate technology. From the beginning of time, when men went to the sea, we have been putting sharp bowels on all of our ships. We do that to reduce the resistance of waves or the effect of waves on our ships. The less resistance, the faster the vessel, the more comfortable the ride. What we want to do is the reverse of that. What we want is flat, hard plates hitting big, hard waves that are moving at about 22 kilometres all day, nearly every day. So our pressure plate system will develop with buoyancy to capture the energy of the waves. In what form does this look like when we are out in the ocean? It certainly doesn't look like this, because this would just sink. So we do have to have buoyancy. Our system will be a barge. We will place a barge out in the ocean 2 kilometres off the shore, connected to the ocean floor with the ability to interconnect with others. But this is the simple system that can convert wave energy, ocean wave energy, into baseload green energy. This is our wave barge system completely together with the 5 units. The purpose of this is to extract energy out of the waves travelling underneath it. Its location is 2 kilometres from the shore, which is back here, and the depth of water has to be a minimum of 60 metres. 60 metres and greater, there's more than enough energy out in the open ocean. At the front of the barge, approximately 200 metres away, are 2 suction sea anchors. Connected to the front of the barge with an anchor cable. because the whole system of the barge is to operate the movement of the wave, you cannot have a direct anchor coming down cables because it would affect the operation of the barge. These barges need to move, therefore we have the buoyancy units connected to the anchor cable that allows the movement of the wave. This also applies to the back of the barge, that it is located but not affected by the anchor cable. Each barge has to interact with the one behind it. That is achieved by the cantilever boom that supports 4 pistons into the next deck of the following barge. Every time a wave moves and reaches up because of the motion of the wave, the 2 outside pistons fill and start to compress. When it drops into a hollow, then the inside pistons load with water and then compress. So with every action of the wave, you are extracting energy. We are drawing seawater from underneath the barge and driving it back into these pistons to be compressed. That compressed water travels between each barge and increases in volume as the barge is operating in different size swells. That water is compressed seawater, is dropped over the back of the barge, down onto the seafloor and back to the shoreline for processing, we'll call it. The loads on this barge at present are next to none. 5 barges would sit in flat water like this very easily, no problem. What happens when there's a 2 metre swell, a 4 metre swell, a 6 metre swell? These all have to be taken in account for the purpose of how we extract energy from the ocean, but do it in a maintainable manner. So what happens when our pipe water comes to the beach? This is the type of a poly pipe fusion welded that would deliver the pressurised water from the barge systems to the beach. This simplistic bit of pipe work illustrates how we turn that pressurised water into energy. Just to give you a bit of a better illustration, the water is delivered into the pipe system or continuation of the pipe system to a turbine located at this point here. The energy is extracted out of and developed into electricity, and the overflow or overburden of water then is discharged back into the ocean. And that happens the majority, especially all day. Your community needs the energy and it's getting it from the barge system. But for weeks, if not months, and at night, you are extracting energy into this pipe. This is the final piece of the puzzle for myself. When I was developing this system, I decided that if we can store energy, we can then go and make the claim of baseload. Behind this pipe is dam walls. This water is discharged into reservoirs that will store the energy at a higher location, and then as required, When the storms come and the unit is sitting on the ocean floor for a day and a half, at that time you can extract energy. When it's hardly any swell, maybe 1 or 2 days, then energy is not coming from the barge, but it can come from the reservoir storing the energy. Hydroelectricity has been around for over 100 years, and it is an extremely efficient way to deliver energy. So whether it's coming from the ocean this way or from the reservoir this way, we can claim baseload electricity. So after our presentation, what have we ended up with? We have a barge system, kilometres offshore, secured, pipework coming into the coast and delivering a huge amount of pressurised seawater. Enough barges out there to service the particular community you are working near, not near the community, 20, 30 kilometres down or up the coast away from it, so that you're not affecting tourism or a minimal amount of disruption to the local community. Your energy, there's pressurised water in pipes, comes to the coast and is either delivered straight into a turbine for the majority of the energy required, and a residue of that energy pumped up into storage tanks that then can be used at a later time when the swell is down or there's a big storm running and your buoyancy system is resting on the seafloor. All of this combined gives us baseload green energy. Yes, there is payment required by the community. You will lose beach space. You will lose areas out in the ocean that we will have to cordon off for the safety of the people anywhere near it. You will have large reserves of water stored. It will be salt water, but all of this can be managed and treated. But at the end of the day, you have baseload green energy. For your comments and for your criticisms, please go to the website and give us your feedback. And if you like it, back it. Call a politician, call a friend, send it to people so that this information can be got out to overcome the media suppression of what is required for our future, for ourselves, our children and grandchildren. Thank you for your time.